Okay, everybody, welcome to our first talk, inaugural talk in our series on artificial intelligence. Today we have with us Dr. Tomi Heimonen, who is the chair of the Department of Computing and New Media Technologies, as well as the academic director for the online cybersecurity master's degree. He's been with UWSP since 2015. Prior to that time, he was a postdoctoral researcher at the University of Tampere in Finland. Did I get it? Okay, where he also earned his Ph.D. in interactive technology. Because of his general expertise in computing matters, Dr. Heimonen has graciously agreed to spend some time today helping the rest of us reach a little bit better understanding of artificial intelligence and the ways that it's being employed currently. So please provide Dr. Heimonen with a very warm welcome as he demystifies artificial intelligence for us.
Thank you for the introduction. For the sake of full disclosure, I do have a master's in computer science, so technically I know what I'm talking about. I haven't done a ton of stuff with AI specifically, but my background is in research, so I've done a lot of data analysis, machine learning, and that kind of stuff, which today that's kind of clumped under the AI umbrella. So in terms of the talk today, I'm going to start with some definitions and talk a little bit about the history of AI. How did we get where we are right now? Because I think that's quite interesting to see sort of the hype cycles and how things go up and down. I'll talk a little bit about the different types of AI to give you an understanding of what is sort of currently possible and what is more so in the future. And then I'd also like to talk about some of the challenges and limitations with AI. Specifically on how AI is being used and sometimes abused these days. And hopefully we'll have plenty of time for a discussion. So I didn't time myself, but I would guess it'll probably take me about half an hour to go through my stuff here. Like any good teacher, I also have some notes so that if I have to spend more time, I can spin a yarn on some other things. All right, so let's start with some definitions. What is artificial intelligence? When I was doing research for this talk, I read through some of the historical stuff that has been said in the past. And this is a quote from John McCarthy from 1956. He's one of the founding researchers in the field of artificial intelligence. And he was talking about the kind of the premise that in time, we can basically simulate any kind of intelligence on a machine accurately, which is kind of what AI is. We're basically simulating human intelligence. Then I went to the National Institute of Standards to get their take on what is artificial intelligence. So they kind of bracket that as a branch of computer science that is devoted to developing data processing systems. So we have some data, sometimes a lot of data that we try to process, and through that process of simulating human intelligence, we try to do things like reasoning, learning, and self-improvement. So what is my definition? Because I'm pretty practical when it comes to computing stuff. To me, AI is basically, we have some sort of computer program. We take some data, we feed that data to the program. The program learns about it in some ways. It might find some patterns, it might infer some sort of statistical relationships, and then it can carry out some actions like make decisions or calculate the probabilities for an event or give you a recommendation of what to watch on Netflix tomorrow. Any questions at this point about the kind of the basic definition of AI? We'll get to what is AI or what is current AI and what is more so the future of AI a little bit later, and I'll try to kind of give you an idea of what we can actually do today and what is something that might take 50 years to achieve. So I also put together a brief history of AI in the 20th century. So AI is definitely something that has been around for much longer than that. Descartes, even back in the day, he had some ideas about, AI, not in those words, but he had some thoughts about what would be possible for a machine to do and what wouldn't be possible for a machine. But in the 20th century, one of these seminal works was in 1950, Alan Turing published an article called Computing Machinery and Intelligence. And that was the basis for the Turing test. So the Turing test is a way to try to figure out if you have an artificial intelligence or a system that can simulate a human being with such accuracy that another human being cannot distinguish that it's not a computer program. So he had some of the basic definitions for that in his paper. And Turing worked for the British government during the Second World War. He was one of their premier crypto analysts, so he was doing all of this stuff with the computers back in the day that didn't really have AI capabilities. So it's quite fascinating what they were able to do already then. Then in '56, there was a summer research project at Dartmouth, and some of the kind of luminaries of the AI field were there. So John McCarthy, Marvin Minsky from Harvard. I think some people label him as a computer scientist, but I think other people would say that he's more of a cognitive scientist. So it depends on which field you're in. Nathaniel Rochester from IBM and Claude Shannon from Bell Labs. Claude Shannon is often called the father of information theory. So he was doing a lot of the basic research on this field as well. And this was the first time that they used the term artificial intelligence in a kind of a research setting. Then in 1966, MIT developed the first chatbot called Eliza, which is a very bad psychotherapist. It was modeled after a human psychotherapist, kind of the patterns that the person was using to run his therapy sessions, and it has very rudimentary natural language processing capabilities. So when you talk to it, it's basically trying to find these patterns of speech, and then it repeats your input back to you and asking you questions. And it's fun for like 20 seconds, but after that, it gets pretty repetitive. Then in 1980, they introduced XCON, the Digital Equipment Corporation. So this was one of the first production expert systems. So it was able to help the company when they had orders for their mainframe computers. It was able to sort of speed up the process of getting those orders figured out. Then in 1997, IBM Deep Blue. Everybody here has probably heard about it, or you were maybe watching that on TV. So Deep Blue was a supercomputer that was able to beat Garry Kasparov, a chess grandmaster, in a chess match or a series of matches. And this was pretty big in the AI field back in the day. And the interesting part of this is that it was using brute force. So it wasn't a particularly intelligent machine, but it had a ton of computing power and had a ton of games programmed into the machine by human grandmasters. So it was basically able to brute force a solution. So when Garry Kasparov made a move, it would calculate the next move that would give the highest probability of winning the game. That's how that went. 2005, there was a DARPA Grand Challenge. So DARPA is the DoD research agency that is funding. They've been funding a lot of the AI research in the US. And they had a competition for autonomous vehicles. So they had a track somewhere in the, I think, Nevada desert that they basically gave researchers the challenge that we have to build a vehicle that can navigate this track autonomously. And the first year, None of the teams managed to do that. Second year, they had multiple vehicles that were able to complete the track. And then obviously at these days we have autonomous driving and Teslas and whatnot. And then in 2011, we had the release of Siri, which is the first modern virtual personal assistant. And that was quite something back in the day. We didn't really we had early smartphones, like the iPhone came on in 2007, but we didn't really have, you couldn't ask questions of the phone. You'd have to type in something or you have to use apps or whatever, but Siri was the first kind of intelligent chatbot, if you will. And since 2011, you know, the work on AI has exploded. Like it's really taken off ever since. Interestingly, there was also another supercomputer, well, more like a really, really big neural network that played against the human player in Go. I'm not a Go player, but apparently Go is a game where you can't just study previous games and like become a better player like that. There's a lot of intuition and strategy that's built into the game. And that was a really hard challenge for AI to figure out. So they built these massive neural networks that were then able to figure out their own strategy to beat the human player. So that was pretty good. Right, so this is not an octopus shrugging. This is the hype cycle of AI. So we started out in the 1950s. Up until sort of mid-70s with the first wave, there was a lot of hype, both in the research field and in the industry that, you know, we have this new technology that we can do all kinds of cool stuff. We can do machine translation of spoken language. We can do all kinds of expert systems and whatnot. And that went on for, you know, about 15, 20 years. And unfortunately, the AI community was not able to cash the check that they wrote back in the, you know, late 50s and early 60s. A lot of the systems that just didn't work accurately enough. And then we had the first AI winter, mid to late 70s. So DARPA pulled some funding. In the UK, they pulled funding on AI research, and everybody's going, oh, it's not great. But then we had the second wave in the 1980s. The first expert systems came out. There was a renewed interest in doing research. There was more funding from DARPA and so on. And then we had the second AI winter because, once again, the systems that were being built did not really meet the expectations. For example, XCon, the expert system, it became too expensive to run. A lot of the technologies that were developed in research, we didn't have the computing power to actually run them. So that's been sort of the recurring theme in AI, like we're pushing the boundary of what is possible with the current computing power that we have. And as soon as we have a breakthrough, then we have a, you know, uptick, and then we have a plateau, and, you know, it goes like that. In the late 90s, early 2000s, we had what I would refer to as the new AI spring. So the renewed interest with IBM Deep Blue and all that jazz. And a lot of the work actually took place in the academia and the industry. So the governments were not super keen on funding this research because they got burned a few times, pulling a lot of like hundreds of millions of dollars into the AI research, and it didn't really work. So companies like IBM, Google, and so on, they kind of took it upon themselves to carry out the research. And now, 2010s onwards, we have what is called an AI boom. So lots of companies, lots of technologies, lots of great new breakthroughs. So one thing that I should mention is Moore's law. So Moore's law was coined by one of the employees at Intel, basically saying that I believe it's every 18 months the number of transistors in a processor, computer processor, is doubling. And that has been the Moore's law actually catching up to that premise has been one of the drivers of what we're seeing today. All right. So that being said, I think we need to talk about what AI is and what AI is not, because I think there's a lot of confusion when you talk to lay people about, what is AI. So one way to categorize AI is to talk about the different levels of capability that the AI can do. The first one is reactive machines. And a reactive machine is essentially a pipeline. You have some data, you feed it into a system, the system reacts to whatever the input is, and then the system makes a decision or recommendation or something like that. The second category is limited memory system. And this is sort of like a reactive machine that can actually look back at what happened. So to quote The Lord of the Rings, the reactive machine is kind of like Gandalf in Moria. It's like, I have no memory of this place. So everything happens in the moment. And the limited memory system is more like, I know your face, when there is dying on the field of battles, like I've seen it before. So that's kind of the main difference. And then we have these systems that are more theoretical at this point, theory of mind and self-awareness. So these are something that we have theorized that an AI, if they can reach this level of capability, then we're going to take the next step into what the AI can do in terms of processing and so on. So if we talk about the reactive systems, like I mentioned, there's no memory. So basically, the AI system has been trained for a specific task, and it takes some input, it delivers some kind of output. When we talk about these systems, an important concept is representation. So a reactive system does not have a representation of the world beyond kind of the very small sphere of its duties. It can understand the world in a very limited fashion that's all related to what it's trying to do. So a lot of the machine learning models that we use in different fields, different algorithms, they are reactive. So we basically feed a bunch of data into the algorithm, and then the algorithm does whatever it's programmed to do. So reactive systems are not typically something that can like reprogram themselves or like make the model better. They just basically do the task that they're designed to do. So Deep Blue, for example, is an example of a reactive system. It just basically was a huge, something like 200,000 games programmed into the machine, and it used that database to figure out how to play the game. A lot of cars these days have these active driving assistance systems, like they brake automatically or they keep you on the lane and so on. I would argue that those are also reactive. They don't try to understand the world beyond the simple task like, if I see something in front of me, then I brake. But they don't try to track the object. They don't try to figure out, is it something that we can avoid, etc. And they can also be pretty annoying when they brake automatically. Then the limited memory AI. So I'm not a psychologist, and we have one in the audience who can answer questions about this stuff more than I can, but based on my understanding, these limited memory AI systems, they try to simulate human cognition more so than the reactive systems. So they're typically based on neural networks and deep learning algorithms, and they take the previous data into account when they make decisions. So, for example, a self-driving car. A self-driving car that can independently steer and avoid obstacles, it has to track what's happening around it. It can't just live like moment to moment. It has to actually track what's happening in the world. So they have some sort of general representation of the world that helps them navigate. So a self-driving car, for example, knows that there are things like pedestrians, there are things like traffic rules, there are things like other cars in the road, and so on. And then it can figure out what to do at any given time based on that. But the data is not stored, so it does not have a permanent memory. It's basically used data to do what it needs to do within the framework of whatever the task is that it's trying to achieve. So some of the typical technologies that these systems use are deep learning and reinforcement training. So they kind of build the memory data that the system has in order to make the model better. So these systems can actually take that data that they observe and train themselves to be more accurate over time. So self-driving cars are one example, virtual assistants, another example, different kinds of recommender systems. So if you're watching Netflix or YouTube or whatever, it learns over time based on what you're watching, what you're liking, you know, what it is that you want to watch. Siri and Google Assistant, they can actually back reference when you're having conversations. So if you ask Siri, like, are there any good movies tonight in theaters around here? It can tell you that, well, there's this here and that there. Then you can say, okay, at what time was the first one? So it can actually remember that it was talking about movies when you talk back to it. Then we're getting sort of in the experimental area. So theory of mind is this sort of system that would truly understand the world and the entities. And we're getting sort of in the field of psychology, philosophy, and other fields that are sort of part of my wheelhouse. But you know, the idea here is that instead of a programmer telling the system that this is the world, the system would actually understand that, you know, this is the world and I'm in the world and there are other entities in the world that have feelings and they have intents and things like that. So I guess these sort of systems would be able to really have a more human-like relationship with people. So instead of it being transactional, like we ask Siri, hey, what's going on today? Siri would actually, I don't know, it would know you, it would understand that you are you and you have some behaviors that you won't like to do, you have some things you hate, you have some things that you like, not just at the level that it has a database of things that you clicked on YouTube. It would actually understand that you like horror movies because they're exciting or something like that. And then the last category is self-awareness. So these kinds of systems, I guess at some level would understand that they exist themselves. So they're self-aware to some level. So this is kind of a typical science fiction AI that knows that it is a being. I think we're pretty far away from having self-aware systems. And one of the interesting questions is like, how do we know that the system is self-aware? And what happens when we have these systems? There's lots of doomsday scenarios about, like, you know, the Terminator movies when, you know, Skynet became self-aware, you know, eradicated people because they're terrible. So yeah, I'm looking forward to this. Is probably something that's going to happen when I'm not around anymore. So it's not like I have a lot of deep interest in this, but I think it's an interesting area to kind of consider, like, how does the relationship that we have with technology change when the technology becomes self-aware? That's sort of a recurrent theme in a lot of science fiction. All right. So that was one characterization. Another one is to talk about narrow versus general versus super AI. So narrow AI or artificial narrow intelligence is sort of this reactive and limited memory system. So it can only do what it's programmed to do. Then we have artificial general intelligence that once we have this, the idea is that it can perform any intellectual task that humans are capable of. I've seen some studies or some surveys done to people that are AI experts, and they're saying that artificial general intelligence is there's like a 50-50 chance that it's going to happen in the next 20 years, but there's a 75% chance that's going to happen in the next 100 years. So this could be something that we can see in our lifetime, but you know, it's kind of a toss-up if that's the case. And then we have the super AI, and honestly, I don't think anybody really can tell you with any degree of accuracy whether this is even possible. Like, can we even build these things? But I think we need the general intelligence first before we start thinking about super intelligence. And what is the boundary between those two? Who knows? Because we don't have those systems yet. But then I guess I should talk about ChatGPT because that's what everybody's interested in. What is ChatGPT? So ChatGPT is a generative AI, which is a fancy way of saying that it's a really, really advanced deep learning model that can generate new content based on existing data. So a lot of the other AI systems work more on the input side. So they can take instant data, they can take images, speech, handwriting, whatever, and they can recognize that input. So if I write a word on the board, the machine vision algorithm could take a look at that and it could figure out what the word is that I'm writing on the board. These generative models basically feed on that kind of data, and then they create what are known as foundation models. And in ChatGPT's case, it's a large language model or LLM. And then it basically builds its own model out of that. So a lot of the traditional systems are based on labeled data. So we have some training data sets that human beings are saying that here's a picture of a cat, here's another picture of a cat, here's a third picture of a cat, here's the 100,000th picture of a cat, and then we feed that into the algorithm and it learns to recognize cats. But with these deep learning models, we can do what Google did, for example, in 2012. They used 16,000 computers and tons and tons of YouTube videos, and they fed those YouTube videos into the deep learning model, and it actually trained a neuron that was specifically for identifying cats. They didn't tell the model that we have to recognize cats, but it built a part of the model that was able to recognize cats. Mm-hmm. It didn't know what a cat is, but it was able to recognize that. So a lot of these ChatGPT-like models are based on natural language processing. So they understand the structure of human language, and then they can generate statistically probable outputs based on some kind of written prompt. So if you tell ChatGPT peanut butter and, it's going to fill in jelly, and then sandwich, like, and then is, however percentage you can use. Now, the problem with ChatGPT is that they hallucinate. So they basically generate nonsensical outputs for various reasons. One of them could be training data. So the training data is noisy, and the way that the model is built, that error is built into the model, and then it's outputted into the content. It could have to do with the model training or the parameters for the output generation. We could, the model might be built in such a way that it always wants to give you an answer, whether that answer is correct or not, but it wants to give you something, so it just gives you the most probable output that is there. And due to the nature of the generative system, sometimes that's not even a real thing. Like it doesn't just take the existing training data, it actually generates something new out of that. So we've had some examples where a lawyer was using ChatGPT to write briefs to the court. And it was actually ChatGPT was generating court cases that didn't exist, but it was happily citing them, And then they were caught and, obviously that was a problem. All right, any questions so far? We're saving them until the end. All right, what are we doing with time? All right, so let's talk about some of the limitations. I'm really interested in the human-centered design of AI. So how can we design these systems in such a way that we take people's needs and intents into account when we build this system, not just because we can build them, but we build them because we are trying to address a need that people actually have. So one problem is equity and bias. We can have technological and statistical bias. So basically it means that we built the system wrong, or we fed it bad data, and then we get incorrect results. So there's a saying in the machine learning field, garbage in, garbage out. So if your training data is bad, then your model is going to be bad, and the predictions are going to be bad. We can also have societal bias. So using the AI results in some sort of unfair treatment of different populations, for example. So as an example, if we use training data that is skewed or biased in some way, those biases are going to be reproduced by the model that we use then for some sort of decision making. Finally, we can have cognitive and social bias, which has more to do with how we actually use the AI. So there have been instances where the AI has been trained with some type of data from some population, and then the model has been used on another population, which obviously is not going to be as accurate because the behavior of that population is completely different. So there are good examples of automatic faucets and soap dispensers that cannot recognize people with dark skin, because they didn't, I guess, have any people with dark skin in the training data that they used to train the system. So there was an article inside the American a couple of years ago. So healthcare organizations are using, or insurance companies are using algorithms to calculate what's your risk of like how likely it is that you're going to require some expensive operations. And I don't remember exactly the details, but they were basically equating the amount of money that you spend on your need for healthcare. And since African American patients are typically underinsured more so than other patients, the algorithm basically was saying that African American patients don't need as much services as other patients, which obviously it's the other way around because they're underinsured. They sometimes need more. Which kind of brings us to the second problem, which is explainability and transparency. The problem with a lot of AI systems these days is that they are very complicated. So a lot of these deep learning models, like there's no way to explain them. Like nobody understands how they work. Not even the researchers and programmers that build those systems. Which is obviously a problem because you want to be able to justify the decision that the AI makes, especially if it has something to do with, are you going to be denied healthcare? Are you going to be incarcerated? Are you going to get a job? Like it would be nice to be able to explain that result. Another problem is that AI is increasingly being used without disclosing that AI is being used to the people that are being affected by AI. There was a case from my native Finland a couple of years ago. The local tax authority was experimenting with AI to automate the annual tax returns process. And me being computer science, I was like, yes, this is great, like, it's gonna be much more efficient now. But it turns out that it was against the law, like, the law actually said that, well, the law didn't say, but the courts interpreted the law in such a way that an algorithm cannot make the decision on your tax return, it has to be done by a human being. So they just wanted to use AI without telling people that they didn't. But then we have this other problem, like if we tell people too much about how the system works, they're going to try to start to game it. So it's kind of a balance, like how much do we tell people about how the system works to preserve some of the secret sauce that like makes the AI actually work. Here's another story from Wired. A woman went to a hospital. She had some sort of pain, and the treating physician punched her information into some sort of computer system, and it came back saying that this person is in danger of abusing opioids, so you cannot prescribe opioids for these patients. And it turns out that the system was not only using data from human prescriptions, but it was also using data from vet prescriptions, because obviously people misuse any kind of opioids that they can get. But the AI system did not understand that this person had a dog that had seizures and required opioids that were meant for the dog. All it knew was that this person has been getting a lot of prescriptions for opioids, therefore they're in danger and we're not going to give her anymore. And it took her a long time to figure that out. Lots of Freedom of Information Act, requests and things like that. Mm-hmm. And finally, security, safety, and privacy. Unfortunately, a lot of the AI systems these days are based on non-consenting data collection. So if it's on the internet, it's basically a free game. So a lot of these AI models are based on scraping content from the web, which has a lot of copyright implications. I just read today that George R.R. Martin and some other authors are suing, I believe, OpenAI over ChatGPT using their material in its model. And even if they tell you that they're using AI, it's buried in the terms of service legalese that nobody reads. So you're basically consenting to AI use without really consenting to it. Another really dangerous trend is that these models can sniff out sensitive information, even if it's anonymized, because they can combine different data sets to figure out who you are, what you're doing, and so on. So there was one study in the DevCon conference, which is kind of like an annual hacker conference. A group of researchers bought some browsing data from German users. It was anonymized, so it didn't have any names or anything like that associated with it. It took them a few weeks to combine that with some other marketing data that they were getting, and they could identify the people based on their browsing history, which is kind of scary. Like, is it even worth going incognito when you're browsing the web if they can still, identify you? And then, of course, we have AI systems that can actually result in serious bodily harm. So they can actually kill you. So we need a lot of really robust governance around these things. There's actually in the European Union, which unfortunately in many ways is ahead of the US in legislation when it comes to AI, they're actually considering a EU AI Act, which would have different levels of scrutiny for different kinds of systems that have high risk or medium risk or low risk. So, for example, they would outright ban some uses of AI because it's considered to be too risky. So one example that I keep coming back to is from, I think, 2016, 2017, something like that. So a self-driving Uber car hit and killed a pedestrian that was jaywalking, because the way that the model was trained, it didn't take into account a scenario where a person would be crossing the road outside of a crosswalk. That's extremely unfortunate. I haven't followed the case. I don't know what exactly the outcome was, but I'm guessing some sort of settlement based on the fact that, you know, a person died. So that's kind of a quick introduction into AI, how it works, how can we use it, and I'd be happy to answer any questions.